Okay, in this exponent problems, we have a lot to do, so we have to simplify. What I would say to do is do one rule at a time. So if we look at the left, these negative exponents kind of confuse me, so I like to get rid of them because it's one less thing you have to worry about. So if you look at 3 to the negative third, that's going to become 3 to the third in the denominator. Alright, and then a to the 11th will stay in the numerator. B to the negative fourth will come down to the denominator. So pretty much what I'm doing is I'm going through each factor in that expression on the left, and if it has a positive exponent, I'm keeping it where it is. If it has a negative exponent, I am moving it to either from denominator to numerator or vice versa, and I'm changing the sign of it. Okay, so that b to the negative second will come up as a b squared, alright, and that c will stay down as a c. Okay, and then everything is raised to the negative first power. Alright, so that just means we're going to also just like find the reciprocal of that. But before I do that, I'm going to simplify this by writing everything with one base. So if I look at like a to the 11th times a to the 5th, that's going to be a to the 16th. And then if I look at like c to the 5th over c, that's going to simplify to c to the 4th because, you know, one of those c's cancels out. And then if I look at b squared over b to the 4th, alright, that's going to be just a b squared in the denominator. Alright, and then 3 to the 3rd times 9 squared, you could just multiply them with the calculator as one big number. Like, or you could rewrite 9 as 3 squared. So since it's like 3 squared squared, it's really like 3 to the 4th. So it's like 3 cubed times 3 to the 4th. Alright, so we get 3 to the 7th in the denominator. So that would be like the best way to do it without a calculator. But if you do have a calculator, you could just, whatever 3 to the 7th is, you could just write that big number. Alright, and then it's to the negative first power, which means everything is just going to flip. So everything gets a negative exponent, so it's going to change from numerator to denominator. So we get b squared times 3 to the 7th in the numerator, and then a to the 16th times c to the 4th in the denominator. Alright, so that's this part right here simplified down. Okay, so now we have to do the other part. So what I'm going to do is work from outside in. So everything, so we got 4a, and then that thing in parentheses, b squared cd to the negative second cubed, all that's being squared. So if you square 4, alright, you get 16. If you square a, you get a squared. And if you square b squared c d to the negative second cubed, it becomes b squared c d to the negative second to the 6th. Alright, so the exponent goes to like all three factors. Okay, then you can now apply that 6th power to everything in the parentheses. So we're going to multiply. So it becomes b to the 12th, c to the 6th, d to the negative 12th. Alright, and then we could just get rid of that d to the negative 12th by putting it in the denominator. Alright, so now we have like these two being multiplied together. So if I just rewrite this, 16a squared, b to the 12th, c to the 6th, over d to the 12th. Okay, now I'm just going to like kind of combine things with the same base. So like b, so we got b to the 2nd times b to the 12th. That's going to be b to the 14th. And then we got, if we look at our a's, we got like a to the 2nd over a to the 16th. So that's going to be a to the 14th. Alright, we also have c to the 6th over c to the 4th. So that's going to be c squared. And then we got d to the 12th. That'll just be down here. And then the 3 to the 7th times 16, you can just rewrite it as that. I mean, without a calculator, I'm not really sure what that is. It's a big number. Not too big, but you could just leave it like that. And that would be an appropriate final answer.